Hi everyone. In this video I want to explain how we can transfer a model from SolidWorks to Adams view if we can't use a plugin option. If your Adams version and SolidWorks are not compatible, you can't use plugin and transfer mass, inertia or other characteristic like mating or joints you created in SolidWorks. You should complete your model inside Adams. Only you can transfer bodies or links. But before that, I prefer to simplify model, not transfer all the parts. Just I want to transfer main parts. Here I have 6 main parts and others are redundant. Sockets, washers or nuts, these are redundant. And I want to export in parasolid format. When you want to export in parasolid format, easily you can hide redundant parts you don't want to transfer, and then export it. These are my 6 main parts. I want to keep them. I select parts I don't want to transfer and hide them. Then going for saving the model. You can export in a step file too, but parasolid is more accurate in terms of keeping the geometry of your model. Parasolid is better format and you find less problems inside Adams. Here it asks, do you want to keep hidden or suppressed parts? And we should select no, because we want to keep the model as simple as possible. Then we go inside Adams and import the model. You shouldn't go for new database when you want to import from Solid. Import should be chosen. And we go to the address of the model. Then we should choose a name. Here I choose ABB. And I don't change the setting, default setting of the Adams. If you enter explode assembly, it explode your model, robot model, and put them in different positions. So for creating joint, it becomes more difficult. So I don't change this. I'm just going for OK. Then we go to view model. Okay, this is a wireframe format of the model without mass, without inertia. We should give mass to the links. But first I go for defining gravity. By default, Adams regard gravity alongside a y-axis. I don't change it, but you can change it. If you want to regard gravity along with z-axis, you can change it from this window. Should select OK if we don't want to change it. Okay, here are parts with the exact name according to the names of links in SolidWorks. We can change it in SolidWorks or we can rename it inside Adams, because these are very long names and somehow similar. So we should give mass, modify. You have 3 different methods to define mass, manually or using library of Adams. I go for choosing material inside library of Adams and define aluminium for all the parts apart from base. We do it for all the links. But for base part, usually it's made of a steel, so I select a steel for it, not aluminum. Okay, and it's better to choose different color for links. When creating joints, we shouldn't be confused by names of links or color of them. But you should go for change it from your solid part, not from a body part. Going to appearance using library of Adams. Just choose different colors. It's not important which color. We do it for all the links. Okay. Then we should define marker, because marker for creating joint. If you look at this model, it has orientation compared to our working grid. So we cannot use the main axis of coordinate system when defining joints. We should have joints according to the orientation of link. I want to use a center of mass marker. This marker would be created after giving mass to the links. I just copy paste it and using its orientation, but transfer it to better position. But orientation is very important when defining joints. Just copy center of mass marker and Adams paste it automatically. Here it's better to first change the name of the links, because it's too long and very similar. We choose simpler name. The last part, which is named base, which should be fixed to the ground. Okay, now I rename it to ref. And modify, transfer it to better position. I don't change orientation. I want to keep orientation of center of mass coordinating system. And so I just pick up a point close to the interaction surface. I want to create a joint between end effector and wrist, the previous link. Wrist is fork shaped, but it's only one link. It doesn't need two revolute joints. Just one revolute joint is enough. I try to choose a point in one of the interaction system. What is on you? Which point you want to regard? The left one or in the middle is on you. I hide one link before because to see better the interaction surface. Okay, we can rotate it to see the marker where it's created. So here it seems it's in a good position. We should do it for all the links where we want to create revolute joint. Then I go for revolute joint method of two bodies and one location, but normal to grid shouldn't be used here because I said links here have orientation compared to grid window. So we should go for another method to choose a coordination system, to choose a marker. So I go for pick geometry feature. The first body usually is parent link, the body you want to orient relative to it, and the second is child. So for the first I go for selecting wrist, and the second is end effector, the last part we transfer, and then we choose the marker we created named ref, end effector ref, and select the axis around which a joint should be revolutes. Okay, it seems the axis is correct. And then going for doing it for other links. Creating a marker from center of mass marker, rename it, and then we should modify it. We should change the location. Okay, I try to choose the location, the better location closer to interaction surface, but I don't change orientation. Select the center of 4R, and then should define revolute joint here. We select bodies and then reference, and select the axis we want to create joints around, and then we can check it. If you want to modify it, you can do it from connectors. Your joints are listed inside connectors, and just you can modify it changing the type or other positions, or even rename it there. Base should be fixed to the ground, and it's not important which location you choose it. Even you can go for normal to grade for fixing it to ground. It's not very important. But for revolute joints, it's very important which axis you define. Should do it for other links too. I did it. I created joins for all the links. Now we want to check it whether they moves correctly or not. So I should create motion, and I want to see its performance one by one. So I only keep one revolute joint, and temporarily I fix the others. Then we go to Motions tab, second one, and we create a motion. Here Adams asks you which angular velocity you want. By default it's 30 degrees per second, and I change it to 10 degrees per second to see it better. So you can go for simulation. I don't change default setting, but if your model complicated, you can change step size and simulation type. I put it on default. Adams can detect which simulation is needed based on complexity of model. So we just simulate it. So this is joint 2, and you can see it moves correctly. I increase the time to see it better. I double it. It rotates correctly. We should do it for other joints one by one. But first I deactivate the motion. If I don't do it, I can't fix joint 2. So first I deactivate a motion and then fix joint 2, and back it joint 3 to revolute. Then we define motion for joint 3, and again 10 degrees per second is good. Simulate joint 3 here to check its performance. Okay, it rotates correctly, but there is one problem. We have collision here. Between base part, forearm, and upper arm we have collision, which is in reality not possible. And that's why we should design controller. Adams is not stopped automatically because of collision. But we should control the body. I do it for other joints. Okay, here I check all of the joints, I define motions for all of them, and for the last time I want to simulate it again. Okay, we simulate the model. So the model moves correctly, and the only problem is this collision. In the next video, next tutorial, I want to use Control Toolkit inside Adams and apply a simple and feasible controller, PID controller, to limit the motion of the links. Thanks for watching this video, and I hope I see you in the next tutorial.